You'll find methods throughout the .NET Framework library. A few examples include the WriteLine method of the console class that writes text to the console window followed by a line break. It does something. The next method of the random class generates the next random number in some random sequence, really a pseudo-random sequence. The WriteElement method of the XMLWriter class writes an element to an XML file. Compare method of the string class compares two strings. And the copy_to method of the FileInfo class copies a file. Now each of these methods has a task to perform. Notice also that the name of the method explains the task that it's going to perform. Specifically, the name is an active verb followed by a noun. And that's a pattern that you should follow when you're defining your own classes. Now methods can take any number of parameters, which can supply further instructions and information to the method. For example, the WriteLine method displays only a line break if it's called with no arguments. To display specific text, you pass that as an argument to the method. The next method doesn't have to have an argument passed to it to generate a new random number. But if you pass a number as an argument, you're specifying that the next generated random number should be less than that number. If you pass two numbers as arguments, you're specifying that the next generated random number should be between the first and second number. So the parameters that you pass to the next method determine or customize the behavior of that method, what is returned from that method. And then methods may or may not return a value. There's no need for the WriteLine method to return a value. It displays text and doesn't need to communicate back to the calling code. The next method, on the other hand, needs to return a value. That's the whole point for its existence. You call next to generate a random number, and you need to know which number it generated, otherwise it's not much use. Therefore, next returns as an integer the random number it just generated. Some methods return a value that indicates whether the method was successful. For example, the indexOf method of the string class tests for the existence of a string within another string. You call indexOf as a method of one string and pass another string as an argument. If the method finds the second string in the first string, it returns the starting position of that second string. If the method can't find the second string, it returns -1. So the return value indicates that it wasn't successful at finding that string within the other string. All right, so these examples give you just a taste of the many ways that you can define and use methods as part of your classes. Now there are two types of variables, value types and reference types. Value types contain their actual value, while reference types contain a reference to the location in memory that stores the actual value, someplace out in the heap memory. And there are two types of parameters as a result, value parameters and reference parameters. This makes sense because parameters are really just variables that store the values that the calling code passes to a method. Unless you specify otherwise when you create it, the arguments passed to a method are passed by value. That's default, by value. Any changes made in the method to arguments passed by value are not visible to the calling code because it's actually changing a copy of the value, not the original value. But you can specify that the calling code should pass arguments by reference by including either the ref or out keywords in the definition of the method. Then any changes made in the method to arguments passed by reference are visible in the calling code. Here's some code that shows a method that takes two parameters, an integer and a string. The method increases the value of the integer by 25 and adds text to the string. So the method just does the addition and concatenation and displays the result. It doesn't return the new values. It's got a void return type, so it's not returning anything from this method. Okay, so that's the method that I'm going to be calling. And here's the code that calls that method. So this passes the arguments to that method by value. So there's the call right there. So I initialize the amount to 25, the greeting to hello, and then I write out a string, and then write out the amount, write out the greeting. So these are the values before I call this method. And then I call the method and pass in the amount and the greeting. So I'm passing in the value of those variables. Again, these are being passed by value. All right, then I do a blank line, and then I once again display the amount and display the greeting. Okay, I'm going to talk about the rest of this method a little bit later when I talk about reference parameters. So I'm going to go ahead and start up the application and select E for value and reference parameters. Okay, so here's the results of running that code. And again, this is the only part that I've talked about so far. All right, so this is what is displayed by the first part of this method. So amount is 25, and the value of the greeting is hello. And that displays because of these console.write lines. So it's just declaring the original values, or displaying the original values. This code is being executed here. So I've passed in 25 and hello. It's added 25 to it, so it's now 50. And concatenated on space world, and so greeting is now hello world. But now look here. Because I passed these parameters by value, this method received copies of the values of those parameters. So anything that I change here isn't going to affect the value of the parameters here. And that's displayed here because the amount is still 25 and the value of the greeting is still hello. Okay, so because the calling code passed the arguments by value, and again that's the default, so I didn't have to do anything strange in here. So there's no additional keywords or anything, so these are being passed by value. So these variables are not visible to this method, and conversely, these variables are not visible to this method, and calling this method doesn't affect the values in this method, in this calling code here. Okay, so the original values remain unchanged. Okay, so this is all different when you pass parameters by reference. So in this case, the behavior of the code is going to change. So here's essentially the same method, but the only thing that I've changed here is that I'm using the ref keyword with each of the parameters. This is what causes the values from the calling code to be passed to this method by reference. So this method is no longer getting a copy of the data that's being passed in. This is getting a reference to the original parameters in the calling code. So now what's happening is when I make a change like this, this is actually changing the value of the parameter in the calling code. This is changing the value of parm2 in the calling code as well. So I'm going to display these, and then if I come back up here to the method, here is the reference part of it. So I'm displaying amount and greeting. Oops, actually here, I'm displaying amount and greeting. So this is going to be redundant here because I haven't done anything between these two sets, but I'm just making it painfully clear that this is still amount and greeting when it's displayed. I pass them to this method by reference, and then I display the values again. Now, an important thing to note is that I have to use the ref keyword both in the definition of the method as well as in the calling code. That makes it painfully clear both to the developer who wrote this method as well as to the developer who is using that method in calling code that these are being passed by reference. That's a very important point because this method can now change the value of the variables in this calling code. And so if you're not aware of that, you don't know that that's going to be happening, you don't know that those values can be changing, that can introduce some subtle, extremely hard to find bugs. So it was a very good design decision for the ref to be required in both the calling and the call to code. Okay, I'll run this again. Again, press E, and now we're looking at the second part of this. So here's the original values. They're still unchanged from here. Then here's within the method. I've added 25, and I've concatenated on world. And then here is the results of then the calling code. The value of those variables have been changed by the method I called because I passed them by reference. Okay, so that's why understanding when you're passing by value and by reference is very important. The behavior of the code changes. And again, to belabor the point, the only change that I made to the code is that I added the ref keyword both here and in the method definition. Okay, there's one more variation to this. You can use either the ref keyword or the out keyword. This is another option for passing arguments by reference. The difference between the out keyword and the ref keyword is that ref requires the calling code to initialize the variable before passing it as an argument. So if I come back up here into the code, a requirement of using ref is that these variables had to be initialized. That's not a requirement with out. It doesn't have that restriction. Okay, so I have this modify params passed as out. I'm declaring them as out. So these parameters are going to be passed in by reference. So far, it's the same as this procedure here. So I'm going to initialize the variables. Now I need to do this because these parameters, when they're passed in, may not be initialized. So I have to do something in this code to initialize them. And then I increase the values, I concatenate the strings, and then I display them here within the method. And then here's the code that exercises that method. All right, so here's the variables that I'm going to pass to that method. Notice that I'm not initializing them. Typically, that means that the C# compiler is going to complain because I can't use variables that are not initialized. I can declare them without initializing them, but I can't use them. But in this case, because I'm passing them to a method that uses them as out parameters, that's not a problem, and you can see that I have no trouble compiling this code. I pass in those variables, and then this method takes care of populating these variables with the values here within the method. So again, I'm initializing them, incrementing and concatenating, and then here I'm displaying them. All right, so I'll run the application, press F5, press F for out parameters, and here you can see that the value of param is 1. The main difference between the previous couple methods is that because these are not initialized, I'm not displaying them first. So the first time they're displayed is here within the called method, and they're called as output parameters. All right, so I've already initialized them, I've already incremented and concatenated, so they first display as 50 and hello world. And then I display the values here in the calling code after I've called the method, and because this method has changed the values of these parameters passed by reference, the values are still 50 and hello world.